Good evening, everyone. Welcome back to the Johnson Space Center for tonight's mission status briefing on Atlantis' flight to the International Space Station. With us to bring you up to date on all the latest developments in orbit are Kathy Kerner, the STS-117 lead shuttle flight director, and Mike Suffredini, the International Space Station program manager. And we'll start off with Kathy.
Well, good afternoon. The crew is in the middle of their Flight Day 7 activities. Those activities can pretty much be broken down into two different categories today. It's all the activities that we do in preparation for EVA 3 tomorrow, and then the to-be retract activities. The EVA preparation activities today included a review by the EV crew on the OMS pod repair. Today was their first day to actually see the repair procedures and to actually do some practice on some of the repair techniques that you heard John Shannon talk about several times in these press briefings. They had a tag up this morning with Mission Control to go over some of those procedures. They had the rest of the day then today to practice those procedures and also to collect and gather all of their tools for the EVA tomorrow and to prepare their suits. They're in the process right now actually of having another tag up with the flight control teams to go over those procedures one more time, and they'll be ready then to get into their camp out pre-brief protocol that they'll start this evening when they again sleep in the airlock overnight. Let's see, as far as to-be retraction, I think a lot of you saw that today. The retract went fairly well at the start. We got to see a couple of bays retracted before we started seeing some hang-ups on some of the guide wires. You see here the solar array. We got really good response after the shuttle crew did the fluffing of the blankets yesterday during the EVA. They distributed some of the panels and released some of the hung-up grommets. And then, of course, after we retracted another couple of bays, we saw some problems. So we think we're about halfway retracted now. I think the crew called down. We were still out about 15 or 15 and a half bays. So that'll give us plenty of work to do tomorrow during the EVA. The first part of tomorrow's EVA is going to be dedicated to the OMS pod repair, and then the latter half of the EVA will be dedicated to the solar array to-be retract. And I think we have a graphic that will show the position of the crew member when they're doing the repair. Danny is going to be the one doing the repair for us. While he's doing the repair, JR is going to be going out and doing the vent valve task that I think you heard Kelly talk about it previously. You'll see the shuttle robotic arm there is extended pretty much almost to its full reach. We've got a whiff extender and then a platform for the crew to be able to stand on there, and he'll do all of the repair techniques again that you saw and heard John Shannon talking about previously. Let's see, as far as the activities for tomorrow, from an events perspective, the crew wakes up shortly after 7:30 a.m. Central Time. The EVA is scheduled to begin about 12:30 p.m. Central Time. And again, we do the OMS pod repair first, simultaneous with the valve replacement, and then the bulk of the EVA will be dedicated to solar array retraction. That's all I have.
Hey, Mike.
Well, good afternoon. Kathy touched on what has been going on today and what our plan is for tomorrow. And overall, from a station program perspective, we're right on schedule. We had, as we've talked about previously, had hoped that maybe we'd be a little further along with the retraction, but from a planning perspective, we're right where we thought we'd be on the plan, and expect to get this array in over the next EVA, and in fact we have the fourth EVA 2 to finish up if we need to. So we have plenty of time to get that array in and get a number of other tasks done, as well as do the OMS pod repair. So this is turning out to be a very good mission for us from the standpoint of accomplishing additional tasks than we had originally planned. And that's important for us for the future flights and the increments. We have a number of tasks that have to be performed in order to get the Node 2 attached, and then to attach the Columbus module and then the GEM. All of this we plan to do in the next year's span. So the first step, of course, is to take care of a few of these tasks that we're doing during this mission, followed by an EVA where we have to discard, if you will, the early ammonia servicer. We have to remove that from P6 before we move P6. Of course, the array retraction during this flight is another step we have to do to P6 before we move it. All of that has to take place, of course, before we get to 10A. 10A is when we move P6 and install a Node 2. And then there's, of course, you know, some reconfiguration tasks we have to do after 10A in order to get the node in its final position and hooked up so that we can bring the Columbus module up. So all these tasks are very important to us. We had laid in some what we call get-ahead tasks, and we believe we'll get a couple of those done. And that just helps us, it gives us the time we think will be necessary during this next EVA to get all of those tasks complete before we jettison both the EAS and a stand we call VSSA, or refer to as VSSA. So that's all going very well. Yesterday we talked to you a little bit about the computer systems on the Russian segment, so I thought I'd spend a couple minutes telling you where we're at today. As you probably heard, our Russian colleagues, once we started doing passes over the Russian ground sites early this morning, they attempted to recover both the SAVAM computers, the central computers, and the TAVAM computers, so we'll call them the guidance, navigation, and control computers so that we can all stay on the same page. They were successful in getting one lane up of each, and as we talked yesterday, that suffices for the job they have to do. We took that opportunity with both of those computers up to command a power converter on in the FGB, and what this did for us, because none were on when they had failed, we were not providing power to the FGB, and so it was busy using its battery power to supply loads, including the Soyuz, which was hanging off of the FGB nadir port, as you know. So that was important to us to go ahead and get that commanded on. It's latched on, and so if the computers shut down after that, we can continue to provide the power. The power comes from the U.S. segment. And in fact, shortly thereafter, the command and control computer did shut down. It seemed to take, they tried a number of opportunities to try to restart it, and they did have it up temporarily every so often, but we didn't get very far along in the activation of some of the systems before it really kind of gave up. During that whole period, however, the guidance, navigation, control computer worked, continued to work, even though it was single lane. That gave us some confidence that perhaps, if necessary, we'll be able to have it from time to time for attitude control. But of course, in order to get all the systems operating as well, we'll need the command and control computers as well. So where we are right now is after the last pass, we took one more attempt at activating the computers, activating the central computers. Like I said, the guidance computers continued to work. And then our Russian colleagues commanded both computers off at the last Russian ground pass and went to work on trying to figure out some more troubleshooting steps to try to get them up and activated in their fully redundant state. The leading theory today is perhaps there is some noise, either environmental, we call radiative noise, or a conductive, maybe in the power lines, that is causing the computers to shut themselves down. We've done some investigating into the computers themselves. They were built in Germany by Daimler-Benz. They were built several years ago. It's a contribution of ESA to the overall space station program, and they provided, of course, to Energia, who built up the service module. During testing, when they were doing integrated testing, they did find that these were sensitive to this power noise, and in fact had a couple of instances on the ground where activating compressors around the test stand would cause these computers to have upsets and shut themselves down. So we know that they do have this sensitivity, and so the leading theory today is we've introduced some noise at a level that now these computers are tripping themselves off, and of course the investigation ensues to try to determine what this noise source is. It does appear to be coincident with the connecting up, not the physical attachment of the truss segment to ISS, but the hooking up of the cables that provide the power to the system. It seems like shortly after we made those connections, our Russian colleagues started to have a problem, and that would indict to some degree perhaps the power system that we've just connected up is perhaps one of the sources of this noise that's causing the computers to trip. So we've taken a number of steps during the day with our Russian colleagues where we disabled a certain power sources along the way. We talked a little bit last night about first having the service module only power on and trying to activate the computers. And of course, we struggled with that a little bit this morning. Then later in the day, we have a switch on the ISS side that allows us, on the US segment side that allows us to shut off the power that would come from this truss segment to the service module. And at the last pass, they tried again to activate the set, and were not successful in bringing up the fully redundant set. And we stood down at that point. We believe because of the way the switches work, we're not totally isolating the circuit from the service module. So this evening, we're taking steps to disconnect physically, unplug the power source from the US segment to the Russian segment that has this power from the S34 truss. And tomorrow morning, first thing, we'll try to reboot the computers again and see if this helps us with our problem. If not, we have a number of steps. Our Russian colleagues, of course, are working very hard on a troubleshooting plan. We also have some tools. We have a number of tools on orbit, including an oscilloscope we can use to help ourselves find this noise and perhaps isolate it. And so we'll take those steps if this next step we take does not alleviate the problem. So I feel like we're well on our way. We talked about this before, but these over the next day or so, these computers will probably be up and down. I suspect to see them in single lanes. I expect to see them in dual lanes. I expect to see them all 3 lanes up and down over the next couple days as we sort this out. But I do fully expect that we will sort this out over the next few days and be able to get back to normal operations. Of course, the next question one would ask is if you decide that it's the power source from the S34 truss, can we continue to operate the space station? The answer is absolutely. The S34 truss has been providing power to the entire US segment with no problems. It in fact is providing right now power to the FGB with no problems. It is not uncommon in this world to have some specific systems that are more sensitive to others, to environmental noise, and perhaps that's what we're dealing with here. We have other feeds we can provide to the service module that come from other power modules on board ISS. And of course, with all that said, if this turns out to be the case, we will go to great lengths to figure out why we're getting this noise, because we wouldn't expect it, and to tend to fix that problem. But that would be our next step. If this turns out to be the problem, that'll be our next step after we recover the computers. So I would tell you we have a little more confidence today. We feel like we're getting a little closer to resolving this problem. Of course, space station is full of surprises, so I'd expect 1 or 2 more as we sort through this. But I feel like we're making good progress toward resolving this issue. And with that, Rob, that's all I have.
Thanks, Mike. We'll take questions here in Houston. Let's start down here and just work our way around. Start off with Mark.
Mark Carreau from the Houston Chronicle. I guess I have a couple questions for Mike Suffredini, and it's probably terminology, but is noise like static, or can you sort of help describe what you mean by that, whether it's too much current or static in the current, or something else that a layperson could understand? And when did the ground passes for the Russian ground site passes begin again, approximately?
Let's see, last question first. They generally start where we get to the point in the ground coverage that they go over Russian ground sites is usually shortly after midnight. And specifically, I don't know the time. Usually about 2 o'clock in the morning is where we do some of our first commanding with our Russian colleagues, so that's probably pretty close. It's early in the morning, and then we have a number of orbits that cover. And if you look at how the ground sites are set up over Russia, the first few, you don't cover as many of their ground sites, and then the next 2 or 3 cover several, and so you get quite a bit of time over the Russian ground sites, and the last few then have shorter coverage, but early in the morning is when that would occur. The noise you refer to. That's a good question. Normally, you've probably all seen waveforms. A nice current trace has a nice waveform that has an amplitude and a frequency. Noise on the system typically will be represented as sort of a ratcheted line instead of a smooth waveform line, and that's what we would characterize as noise. If you want to know what it is, every one of you guys that has a BlackBerry, you put it next to your speakerphone and it starts rattling. Well, that's radiative noise, and that's why you're getting that static. Every time your AM radio gives you static, I mean, that's the kind of thing we're talking about. Many devices are not very sensitive to it, but some complex systems are to that sort of noise. And so it can either be radiative, like I told you, like your BlackBerry would do, or it can be conductive if you have a plug plugged into a power source and that waveform is ratty. Some systems can't take. And what it essentially is your voltage and your current is varying, and it varies too much, and the system can't handle that. So that's what we're talking about. What specifically is the cause, we don't know, but we do know that these computers are sensitive to that, and we do know that this problem started to occur after we connected S34 truss, and so that's why we're now suspecting perhaps that might be a player in the problem.
Let's see. VOA.
Sorry, no, Ed Stoddard with Reuters. Sorry, could you explain just a little bit more for layman's terms what you mean by that noise? I'm still a bit unclear on exactly what you're getting at there. And I was also wondering if you could just tell us a bit more just about the cables that you think are causing the problem. Exactly what their purpose is for again.
Well, we don't know what the cause of the problem is. We, because of coincident to when we hooked up the S34 truss and the problems on the Russian segment, we suspect perhaps the power coming from that truss to the Russian segment could be a source of the problem. And so therefore, we have because of how we feed power, the S34 truss primarily is for power to the US OS part of the ISS. We are set up to provide power to the Russian segment, and we do that to very dedicated feeds. So fortunately, in this case, it's a single power feed that is not bundled up in another cable and goes to an independent connector. So because we have this single feed, we're able to actually go and undo this connector. Now we have switches that do the same thing, but the switch, instead of cutting off both the power and the return line, it cuts off just the power line. And so you end up with this common ground, if you will, that's not cut off. And so your source, if you're getting any noise on this line, that noise can find its way back to the Russian segment through the ground. So that's why we feel like we need to unplug it now to totally disconnect the power from the S34 truss that's going to the Russian segment. Again, noise is a variation in a signal. So if I'm providing power it's supposed to be at 15 volts, it's 15 volts plus or minus a volt. And it's over a certain period of time, and if I'm providing 15 volts plus or minus 2 volts, that's more than that particular system can handle. Then this is the kind of issue that you worry about. And some systems can take variations like that, and some can't, and generally they're in their specs. That's just an example of power. That's really a power quality discussion. That's what we refer to as power quality. So if I'm supposed to be providing 15 volts, and I'm supposed to be providing 15 volts plus or minus a volt, that's my power quality spec. That's what I'm supposed to do. If I'm providing greater than that, then I start to violate my power quality spec, and the system can react to that as it would react to anything that's outside of its bounds. Noise typically is referred to as, I'll say, radiative, and so in this case, the best analogy I have again is your BlackBerry next to your speakerphone. When it tries to radiate, other systems are affected by that frequency that's being transmitted. A power line has a certain magnetic field around it as well. That can affect systems near it. I mean, so that's what we're talking about. Now, I'm telling you in generic terms, I'm discussing this in generic terms because we don't know exactly What the problem is, again, we have this incident where we connected the S34 truss and the Russian segment started to act up, and it had been very solid prior to that. So once we disconnect, if they start to work, then we'll go to the trouble of trying to figure out what exactly was going on. We might have a grounding problem, for instance, and that would be something we'd go off and look at. So noise is kind of a generic term for a number of different things that could be causing this problem related to the environment, the radiative and electromagnetic environment induced inside the system.
Tarek.
Thank you. Tarek Malik with Space.com and Space News for Mike. It sounds like you have a fairly good plan going into tonight. Are you, I guess, comfortable and at the point that you feel that you won't need the shuttle to stay in at an extra day, or if not, then I guess when do you have to make that call?
I'm not far enough along to know that. So what we will do is keep all the cards in our pockets. So we will continue to work with our shuttle friends to protect as many dock days as we can while we finish sorting this out. Again, I'm telling you, this is the leading theory today. And so, you know, don't get up tomorrow and expect it to all be working. It may be working a little bit better. It may not be working at all. All three lanes may be up. I don't know what's going to happen. This is the leading theory that we're working to today, based on circumstantial evidence, basically. And that's what we're working through. But we don't know enough today to say we don't need the extra day or we do need the extra day. So we won't give that up right now.
Let's do Patrick and then come back to Mike. Patrick.
I'm Patrick Peterson with Florida Today. I was wondering about the choice of Danny Olivas for the EVA to do the tile repair, being as this is his second spacewalk and maybe not be as experienced as J.R. Riley, and yet I think he has some more experience in thermal protection systems. So why was he chosen for that? Was it the luck of the draw, or was there some particular reason?
Well, first off, the task is actually very generic in nature from an EVA skills perspective. All crew members go through training for TPS repair. So to a great extent, one crew member is as well trained as another on the generic skills. This task is considered overall from an EVA perspective fairly straightforward. So we didn't have a preference on one crew member versus another for the OMS pod repair task. However, that being said, we did have a slight preference for Jim Riley to perform the vent valve installation. He trained most extensively with that equipment prior to it actually being flown, so he's familiar with the hardware. He's also done the most training on that specific task, and since we were going to do those tasks in parallel, it just made sense for Jim Riley to do the vent valve installation and to have then Danny perform the OMS pod task.
Is it now possible to rotate the new solar array? Is the P6 array back far enough so that the other one can go around without striking it?
The answer to your second question is yes. The answer to your first question is no. We have a number of launch restraints, as we reported, I think last night. It's all kind of going together. But I think we reported last night that the crew removed all the launch locks, but the 6 launch restraints still remain. So those have to be removed. We said 3 had been they removed the torque, and the other 3 they hadn't got to at all. In addition to that, we have a little work to preload one of the drive lock assemblies, one of the 2 motors that drive the Sarge. We have to do that. So assuming we have time when we get back out there, first thing we'll do is do the preload on the drive lock assembly, and then we'll remove the launch restraints. If we get those all done, then the solar array is retracted enough to allow us to move the Sarge. And we're not, unlike the other mission, we really need to make sure we could drive the Sarge. We're not quite as the same power bind, so we're not in a big hurry. If we need to delay activating the Sarge, we can do that.
Mike?
Thanks. Mike Schneider, Associated Press. Question for Kathy. Can you just talk about which systems on the shuttle have been turned off to preserve cryo, and whether any activities are being limited because of that?
Well, first off, activities are not being limited. What we've done is we've done some proactively done some power downs in order to save some of our cryogenic oxygen. That's our limiting consumable for our fuel cells. One of the things, for instance, that we did just before I came over here was we decided, since we weren't using the shuttle robotic arm, was we powered down the shuttle robotic arm this evening. We're not going to be using it overnight. We don't need any of those cameras for any activities, so we took advantage of that power savings. We powered down some of our MDMs or some of our computers that give us insight into certain systems. Again, those systems don't necessarily require that insight, so we powered those down today. Some heaters, just in general, we're kind of working through the systems and seeing what we can power down that would help save overall our cryogenics, so that hopefully we can accumulate enough additional O2 to provide as much resources as Mr. Suffredini needs.
And also, a question for Mike. From what the impression is down here, the ISS is a pretty noisy place to begin with, and I was just wondering, I mean, what would be different about this S3, S4 truss noise, say, different from any of the other trusses? Or
You mean noisy how? You mean audible noise?
well,
Is somebody telling you we're loud inside the ISS?
audible noise, sure. I mean, that's what the astronauts seem to always say.
Oh, okay. Let's see how to respond to that. That's a different type of noise. So it's in a different frequency range that you're talking about. The term noise is probably a bad term to use, but it is the one we use in the electromagnetic field. So it's different than audible noise. We could spend a week talking about the noise level inside the ISS. Overall, the noise level in the ISS is very good. There is one part in the service module that tends to be loud that we're working on, but the rest of the ISS actually is, from a crew perspective, is very good, and it's well within the spec that we designed the ISS to early on. But this is totally different noise. And the power source coming from the solar arrays that have been on orbit has been very clean, if you will. We've been well within our power, what we refer to as our power quality spec. And so my guess is if this turns out to be the source of the problem, that something is amiss. Something is amiss, and we'll go figure out what that is. Perhaps one of the power boxes has got an anomaly. Maybe there's a cable that's not hooked up all the way. I don't know. But I wouldn't expect this to be a design issue, if you will. It's probably an anomaly that's not showing itself readily, if this turns out to be the problem. And I caution you not to run too fast. We do these things one step at a time. You try not to shotgun these fixes, or you don't know what thing you did fixed your problem. And so we try to take a very staged approach. We start with a fault tree to say, here's all the possible things it could be, and then we try one at a time to remove things off the fault tree. And we try not to fix too many things at one time, or you don't know which one of those things fixed it. So this is one of the steps in the fault tree, and we'll try it and we'll see what happens. And if it fixes it again, I think then we're dealing with some sort of anomaly, and we'll go work through that.
Mark, follow-up?
Can you, Mark Carreau from the Houston Chronicle, could you explain which power source was providing this circuit power before the change? Was it the P6 or the P3, P4? And I have a follow-up.
Most recently, P4. P6, of course, was providing power before P4 did. We did transition over to P4 to provide power to the service module, and in fact, the power converters we have active for the service module right now are back being powered from P4. So we'll go back to a configuration we knew was working when we get the computers back up.
And to follow up, can it remain on that circuit even though you activate S3, S4? Is there some way to give it the power I mean, if this turns out to be the case, to give it the power feed that it's most comfortable with?
Yes, that won't be a problem. In fact, we have switches, so we can decide which of the power converters we want to feed power to and from what source. So we'll have at least 2 sources to choose from for the service module. I can't remember if we have another set that we can provide or not. I don't remember off the top of my head. But as long as I have 2 from managing power across channels, I feel pretty good that we'll be able to manage that. And again, I can provide power to the FGB from S3-4, and so part of whenever we feed power to Rudgeon segment is how much we give to each of those segments. So if it turns out this is a problem, then what we will do is we'll just keep the power removed from the service module from 3-4, and that won't be a problem for us to manage. Now again, we want to sort through, this would, to us, if this was the problem, this represents an anomaly, and so we'd like to go figure out why that's happening and fix it, and then we would, of course, go back to some sort of nominal configuration.
And just to follow up on that a little further, I want to see if I can kind of follow what you're telling us in maybe a little more detail. But let's say you got lucky in the next 24 hours and you got the computers back. Do you still want to sort of see how the system operates if you start rotations at S3, S4, or do you not need to go that far to kind of do your troubleshooting while the shuttle is still docked?
Well, given the anomaly, I think I'm going to follow up on that a little bit. But given the anomaly, I think it will be obvious to us whether we've solved our problem or not. We have not, over the last 2 or 3 days, been able to get all 3 computers to come up when they go down and try to bring themselves up. They're supposed to try to bring all 3 up in a set. I talked to you about that a little bit last night. The way these computers work, they lose sync every so often, and the way we treat them is we just let that happen. And when 1 loses sync, then 2 operate for a while, and when 2 lose sync, then 1 operates for a while. And finally, when the 3rd one loses sync, it goes down. The whole system gets rebooted. All 3 come back up. We hardly miss a beat, and we keep going. We have not, the system has not been able to do that. So tomorrow morning, if we try to reboot these and all 3 come up, I suspect that right away we'll know whether or not we've tackled this particular problem. Now, with that said, we will not declare victory. We will not ask Shuttle to start consuming lots of O2. We will let it operate for a while and make sure that's the case. Relative to rotating the Sarge, that's as long as I have, if I feel like I've got good terminal computers running, then I can certainly feel free to go operate the Sarge, because then I can desaturate the CMGs if that occurs. We can also allow ourselves then to maneuver and do the dumps that we would eventually like to do from the shuttle. So if I get 3 up and they're running, then we probably from a what do we want to do during the mission standpoint, we'll probably go back to more of a nominal timeline, other than the fact we'll probably, just because of the way we are, we'll probably wait a day or 2 before we start. Actually, what we're going to do, the shuttle guys, is we're going to take as much of their O2 as they'll give us, and we're kind of holding off on that until we figure out whether we've solved this. So we'll probably wait a few days. If we get lucky and it seems like they're all working, we'll probably still wait a couple days before we start siphoning off oxygen from the shuttle, which is important to us too for our long-term logistics standpoint of keeping our big O2 tanks full on the outside of the airlock.
Okay, did you have a follow-up?
Yeah, sorry. You mentioned that you might try to do some get-ahead tasks. Could you go over those in a bit more detail?
Well, I think that's going to, if we get them, they will occur in EVA-4. The things we've got planned now are all what we said we would do during the mission. If I was really good at my job, I could remember them all. But one of the most important that I'd like to see us get done, after we've got 2 things to do that we're working on. One is we're putting the vent valve on that you heard us talk about. After we do that, we have to go do a configuration inside. Then the crew has to go back and actually open that vent valve. So that step has to happen. Whether that would occur during this EVA or not, I don't know. So but I'm hopeful that we'll get that second step done as well, so we can then use the vent. If we don't, we can come back and do that during the stage. It's a very short task. You just have to be there. It's a fairly quick step to open the vent itself. The other more significant one in my mind is there's 2 video stanchions that are sitting on what I told you was VSSA video stanchion assembly. There's an extra S in there for something I don't remember right now. It's sitting on ESP2, the pallet outside, and we need to clear that location to bring up some spare components that are coming up on the following flight. So, as I mentioned earlier, the EVA that we have coming up during the stage is going to jettison the both the early ammonia servicer and this video stanchion assembly that's on ESP2 to clear that spot for another spare ORU we want to bring up. Before I do that, I have to remove the two stanchions and install them in their proper location. I have time for one of those during EVA 9, so we'd like to get another one done during this EVA. So that's the one I remember off the top of my head that's sticking in my mind, because I need to get that one done to get to my next EVA. I knew them before the whole mission started. I've forgotten. Kathy, you don't remember, do you?
I don't have a list with me, but we can provide that to you.
We can get you that. Okay, Mark, the final question.
Mark Carreau from the Houston Chronicle for Kathy Kerner. Is the shuttle kind of prohibited from discharging any water until the attitude control problem is solved? And if so, when would you like to be able to do that?
I'd say I wouldn't say that we are prohibited, but clearly anything that could potentially disturb our attitude is something we want to avoid. In order to do any kind of, like for instance, a wastewater dump, which we had previously planned for today and we've deferred a couple of days, in order to do that we have to be on shuttle attitude control anyways. And so, as you saw previously, we had difficulty handing back and forth between the shuttle and the space station. And since we're holding really good attitude right now with the USOS control moment gyros using momentum management, we don't want to perturb that, and we want to be able to prolong sort of that steady state for as long as possible. It also allows us to save some shuttle propellant in the event that we have to hold attitude for any length of time later on if we have problems again with attitude control. So, right now our attitude control is really good, and so we just don't want to perturb that until we get the situation squared away with the Russian computers.
How long do you go before you have to discharge?
Well, it depends. Our plan pre-flight again was to do a dump on flight day 7, but we can move that out actually as late as flight day 10, and perhaps longer if we take advantage of some other resources. If we're going to keep to our baseline plan, which is to actually do a dump, then I think flight day 10 or thereabouts is the time frame we'd want to do it. We always have other options, though, for disposing of waste or for managing the wastewater, and we're looking at those options right now. It's just that's non-standard for us, so we'd prefer not to do those if we don't have to.
Okay, that'll wrap up the questions. A few programming notes before we close. Right after we finish the briefing, we'll run a 3-minute video clip of the OMS pod blanket mock-up at the Kennedy Space Center that was flown to Texas for testing today. At 8:58 p.m. Central Time tonight, Atlantis' astronauts will conduct a series of media interviews that will be broadcast on NASA television. And our Flight Day highlights package of all of the video of the day's events on orbit will be broadcast on NASA TV at midnight Central Time, 1 a.m. Eastern Time. The highlights will be replayed throughout the crew's sleep period. You can follow all of the activities of the STS-117 mission and the International Space Station on the NASA website at www.nasa.gov. That's it for now. We'll see you back here tomorrow. Thanks a lot.